everyone, let's walk through this physics challenge on the board. We have define progressive waves. That's the first question. Then next, we have a plane progressive wave is represented by the equation. This is the equation where y is in millimeters, t is in seconds, and x in meters. That is the distance traveled by the wave. So our task is to calculate the frequency of the wave, wavelength of the wave, and speed of the wave. So the first question is for us to define progressive waves. Progressive wave, example of progressive waves are the ones we see on water surface. Just like when a stone or a pebble is thrown into a still water of a pond, okay, the particles become pressed. That is, they become pressed and they begin to they move outward, from the center of disturbance in form of ever widening concentric circles like this, in form of ever widening concentric circles. So, which means that for progressive waves is a wave, okay, produced, okay, by transferring energy from one point that's by transferring energy from one point to another through a medium without transferring what we call matter. That means that's for progressive wave, momentum and energy will be transported through the material medium, okay, without transferring matter, okay. So that's in the case of progressive wave. Just like when we have a series of crests, when series of crests are formed, okay, as an object passes through a point, in water, when it passes through a point, okay, in a water medium, then a series of crests or concentric circles will be formed. That is, they will move outward in form of ever widening concentric circles, okay. But in the case of light wave, that's electromagnetic wave, they will move out in form of ever widening concentric spheres, because electromagnetic wave is a three-dimensional wave. But for progressive waves are two-dimensional wave because of crest and trough. Okay, so first question, progressive waves. Okay, progressive waves. These are waves, okay, produced, okay, these are waves produced in a medium. These are waves produced in a medium, okay, when energy, okay, is transferred, when energy is transferred from one point to another, through the medium, okay, without transferring matter, okay, without transferring matter. So progressive waves are waves produced in a medium, okay, because like I said, it's going to form a series of concentric circles. That is when ripples are seen on water surface. The ripples is what we termed as wave, okay. So progressive waves are waves produced in a medium, okay, when energy is transferred from one point to another through the medium, okay, without transferring matter. All right, so the second question, we are given the equation y equals to 0.5 sine parenthesis 100 pi t minus 100 pi x over 17, where x is in meters, t is in seconds, okay. and y is in millimeters. So our task is to calculate the frequency of the wave. So to calculate the frequency of the wave, of course, we know that um, a progressive wave, a progressive wave equation, okay, can be given by y equals to y subscript m, which is the amplitude, parentheses wt. In this case, we have wt minus kx, minus kx. Okay, we have wt minus kx. In this case, we have kx to be negative. Okay, we have kx to be negative. That is the way this equation is modeled. Okay, all right. So the amplitude is 0.5. We have y subscript m to be 0.5. So in this case, what we are going to do is to equate where we have time t in the given equation with when we have t in the what general equation. Okay, this is like a general equation. Okay, all right. So in this case, the first question is to calculate the frequency. So to calculate frequency f. Okay, now we're going to equate wt, okay, this guy, okay, and this guy. That is, wt will be equals to 100 pi t, and we know that w, which is omega, is 2 pi f. So which means 2 pi ft is equals to 100 pi t. So if you divide both sides by pi t, okay, if we divide both sides by pi t, on the left hand side we're going to have 2f, okay, while on the right hand side will be 100. So then if we divide both sides by 2, then we're going to have the frequency to be 50 hertz. So the frequency of the wave is 50 hertz. B, we want to calculate the wavelength of the wave. So which means to calculate the wavelength of the wave, we then equate negative kx and negative 100 pi x over 17. Okay, so also to calculate lambda, okay, we are going to set this guy to be equals to that. So we're going to have, let's equate negative kx will be equals to negative 100 pi x over 17. 100 pi x over 17. Now, we can see x on both sides. We can see minus on both sides. So we have k to be equals to 100 pi over 17. This is the wave number, which is the number of waves per distance. So we need to write k. We know that k is 2 pi over lambda. Okay, so this continues here. So we then have 2 pi over lambda to be equals to 100 pi over 17. So we can see pi on both sides. So we again divide both sides by pi, so that then also 100 divided by 2, that will be 50. So in this case, we have 1 over lambda equals to 50 over 17. So if I flip this, wavelength will be 17 over 50 meters. Let me leave it this way. So that's the wavelength. Okay, so now the last question is for us to calculate the speed of the wave. So to calculate the speed of the wave, which is v, okay? To calculate the speed of the wave is equals to frequency multiplied by wavelength. So we have the frequency to be 50 hertz, and then the wavelength is 17 over 50 meters. So we then substitute. So we have frequency to be 50 hertz, lambda equals to 17 over 50 meters, so that v will be equals to 50 multiplied by 17 over 50. So when 50 cancel 50, then we have the velocity or speed of wave to be 17 meters per second. I'll see you in the next video. Bye-bye.